Adda 24/7. We are in ABM summary session today. Now, what is this ABM summary session? Whatever we have covered in the YouTube series up till now for ABM module A, we'll be covering all the important topics over there. What is important over here? Because everything can be covered, obviously. So today's important summary topic will be covering correlation and a regression topic. Why? Because correlation and regression forms the base of simulation, of sampling distribution, of time series, as well as of this estimation. So all the four topics of statistics in your module A are dependent on correlation and regression. If you understand the theory part of that, you'll understand all the topics. Okay, so that's why we'll be covering that. So let's start. Correlation and regression. Firstly, understand the concept of correlation and regression. Correlation is a statistical technique that can show whether and how strongly the variables are related. Now, what do you mean by this? Understand the concept first. If you understand the concept, then you'll be able to answer it in the exam also. There are many theory questions being asked on correlation and regression. So it is a statistical tool. Basically, this whole chapter module A completely it's of statistics. So statistical technique that can show whether and how, see here, both whether also and how also. Strongly the pairs of the variables are related. See here, pairs of the variables. So important word over here are, I have marked these in yellow. Okay, statistical, whether and how, and pairs. So correlation is mainly related to pairs. Means what? Two elements. Correlation will always relate to two elements. Okay, so it is a statistical tool. Whether and how the pairs of variables are related. Their relation is shown. What do you mean by relation in over here? I'll give you a simple example. Let me take the example of this rates. RBI increases, let's say the repo rates, interest rates. Okay, repo rates are increased. So what happens to the prices of the bonds? Prices of the bonds What happens to them? Who can give me the answer? Means prices of interest rate goes up, then the prices of the bond will go up or down. What will happen? JIB, right? You had this in JIB. So the prices of the bond will go up or will they go down? They'll go down. So this is known as correlation. A relationship and whether and how strongly the pairs of variables. These are the two variables, repo rate and prices. These are the variables. How they are related. So here, what can you say about this? How they are related? They are inversely related. Inversely. Okay. So they are inversely related. Okay. For example, height and weight are related. Generally, taller person tend to have higher, to be heavier than the shorter people. So that is a commonly seen thing over here. So this taller person tends to be heavier, means the weight of the taller person is heavier. Now, there can be exceptions. You can definitely tell me, sir, it's not that. I'm having somebody in my relative, somebody in my neighborhood, who's very heighted, but very less weight. There are exceptions. Exceptions are there everywhere. Okay. Only the point is generally followed formula or generally seen trend is mentioned in correlation. Okay. Otherwise, exceptions can be there in every now and then. We say drinking is bad for health, right? We see so many persons who are the drunkards live up to the age of 80, isn't it? Somebody who's not having any tobacco or drinking habit dies of cancer. There are exceptions. But what does it mean? Correlation shows you the generally seen trend between the two statistical parameters. Okay. Regression is a statistical measure used in finance. So, statistical measure used in finance, investing and other discipline. Now look at this, it's in finance, investing and other disciplines that attempts to determine the strength of the relationship between one dependent variable and a series of changing variables. Now look at this. One variable and series of other changing variables. So what is the difference between correlation and regression over here? Correlation means 1 to 1. 1x and 1y. That is correlation. Okay, that's why it said pair in correlation. And here it is. See this 1y. Y is always 1. But x are many. X multiple, I'll write it. Many. I'll write it many. Many x and 1y. So that is regression. Always remember this. Okay. Regression. So it is a statistical measure used in finance, investing, and other disciplines that attempts to determine the strength of the relationship between one dependent variable and series of other changing variables. Okay. So these are known as independent. So remember, changing variables or many variables are x, and one dependent variable is only one y. Okay. Regression and correlation analysis show us how to determine both the nature and strength of the relationship between two variables. Both nature and strength. Both are shown over here. Okay. So regression analysis will give you both. Okay. Next. What is the difference between correlation and regression? Regression establishes how x causes y to change, and the results will change if x and y are swapped. Now what do you mean by this? Understand the difference. See this. Regression means what? Suppose if I am having this line, okay, one is x and second is y. This is the graph I am drawing. Okay, so if I am having regression and I change this x to y, I change this to y, and I change this y to x, then the answer changes. So in the regression, the answer will change. Here tends to change. Answer will change in case of regression. Whereas in case of correlation, with correlation, x and y variables that can be interchanged and get the same result. So even if I change x to y and y to x, in correlation, the answer does not change. Simple? Clear everyone? So now let me ask you the question. Suppose if I am having 1x and 1y. 1x and 1y. So that will lead to what? Correlation or regression? Type fast. That will lead to what? Correlation or regression? It will lead to 1:1. So it will be correlation, right? Suppose if I am having multiple x. Multiple x means what? Here, I'll give you various x's over here. Practical example I'll give you. Suppose if I am increasing, I am having on x repo rate, repo, or I might have CRR on x, or I might have this SDF on x. SDF means what? SDF. Okay. So that is a standing facility given for these banks. Okay. So these are rates at which the banks keep the excess money with the RBI. So I can have multiple these points over here, and on the y I am having only 1 point. 1 point means price of the bond. Price of bond. Okay, that is the only point I am having. So this is known as what? Regression or correlation. Three points on x and 1 point on y. So what is that known as? That is known as, everyone, 3 are there. So it is regression. 1:1 correlation. Got it? Second point, second question. Suppose if I am having repo and price. So if I have this graph, look at this. Let me remove this now. Okay. Now let me have it again. Okay. Now I am having repo over here and price over here. Okay. Now what happens? What do? I change this repo to price over here. I bring price over here, and let's say the graph is like this. Like this. Now what happens? I change this graph again and I bring price over here and repo over here. So now what will happen? This line was earlier like this. Now the line will go like this, near to repo. It was earlier near to repo, again near to repo. So the line changes. the result changes. So as the result changes, see this is known as what then? Which one? This is known as regression or correlation. As the result changes, it is known as regression. Correct? It is known as regression. Got it, everyone? Correlation is a single statistic or data point, whereas regression is an entire equation of with all the data points that are represented with the line. Now, what is correlation? Single statistic. Single statistic means what? See here, correlation always be studied in terms of R. R is known as what? Coefficient of correlation. Coefficient of correlation, that is known as R. That always studies the relationship between 2 points. Always, any 2 points it studies. Whereas regression is an entire equation. See, this line is known as a regression line. This is the regression line. Why? Because it's a line. It's not a single element or single point. Okay. Whereas regression is an entire equation with all the data points that are represented with the line. With the line means what all points are there on the line, all will form the, means all will prepare this regression line. Okay, how is this regression line prepared? Here, firstly it's called a scatter diagram. I'll have a scatter diagram, and what do? I'll draw that line which best fits the points over here. Now let me show you an example over here. Let me erase this. Okay, so now let me show you this. How to draw this regression line. Suppose this is X and this is Y, and we are having the points over here 1 2 3 4, like these points I am having. Okay, these points. Now tell me, suppose if I ask you to draw a best fitting line out of this, best fitting. So will you draw the line like this? Let me mark this over here. Will you draw the line like this, which is best fitting over here? Or will you draw the line like this, which is best fitting over here, this one? So which one is correct? Let me mark this as A and this as B. So which line is correct as per you? Best fitting line. Is A correct or is B correct? Everyone? Correct. It is A that is correct. Why? Because it is covering maximum number of points. So that's why regression line means what? This is known as a scatter diagram. Whatever points I have scattered over here, that is known as scatter diagram. Always remember this, scatter diagram. And in that scatter diagram, I'll always draw such line which will cover maximum number of points. Okay. So this is known as the regression line. So that's why it's mentioned. Regression is an entire equation with all the data points that are represented with a line. So what are the two differences now? In correlation, even if I change X and Y, then nothing changes. In the regression, it's reverse, right? Whereas correlation is a single point, regression is a complete line. Also one more. Correlation is a statistical technique that can show whether and how these variables are related, that we already know. So that is, these are the two main differences, right, between correlation and regression. So this was a theory of correlation and regression which we wanted to cover. Now, here there are other numericals as well. I have covered them in my earlier lectures. Kindly follow them on YouTube. Okay. At the same time, I have covered. You can just type my name and Adda 24/7, or see my face given on that thumbnail, and start reading it. Okay, so I've covered it in detail, all the numerical. There is a case study which is covered on correlation, very important case study. Okay, everyone kindly download Adda 24/7 app on your mobile. In this app you will be getting all the premium study material plus live classes, ebooks, tests, everything. Whatever we need for clearing JIB and CIB, you will be getting it over here. So what do you need for clearing JIB or CIB? Basically CIB, because CIB is very tough. We need first lectures. So we have video lectures over here. Second, what do we need? We need books. So we have ebooks over here, notes, ebooks, we are having it over here. For checking your knowledge, you need tests. So we have tests over here. So all the three elements are included. So why do we waste our time then? Here and there. Okay. Don't go here and there. Directly download this Adda 24/7 app and you get it over here. Start studying, isn't it? Now let's come to the questions. Now these are the basic questions of module A. They are not only related to correlation, but they are related to various other topics also. That's why we have a summary session today, right? The following are the marks of 9 students in a class. Then the median is, so these are the marks of 9 students. Now to find out the median. What is the median basically? Median means, number one, there are 2 points on median. Everyone should understand this properly. Firstly, when I arrange the data, see here, arrange the data in a serial order. Now this serial can be either ascending or descending, both. Okay, serial order. And then I find the central number. Central number. Okay, central number, and that becomes the median. Okay, now let me show you 2 examples over here. One is, see this, these are the numbers. Now what we'll do, we'll first arrange them in a serial order. Let's say ascending. We'll arrange them in ascending. Okay, so what is the ascending order over here? Everyone pay attention. 21. First is 21. Second is what? After 21, what comes? 24. Is there anything else? No. 24. After 24, 27. Or anything in between? No, 27. After 27, then 28, 29, anything? No. 30 directly? 30 we are having. 30. After 30, we are having 32. 31 anywhere? No. 32 directly. 32. Then after 32, 34, right? 33 is there? No, 34. After 34, 35 is there, right? We are having 35 also. 35. So 35 is done. Anything else? How many are there? 4, 5, plus 2, 7. 2 are remaining. Which are the 2 ones remaining? These two, 38 and 48. So 38, I'll write it over here now. 38 and 48. Now we have arranged them in serial order. So arrange the data in the serial order, then find the central number. So central number means what? How many numbers are there? 9. So central means what? 4 out from this side, these 4 out, and these 4 out. So my central number is 32. So my median becomes 32. Okay. Now you will ask me one question. Suppose there are 9 students. That's why this central number. Suppose imagine I give only 4 numbers. 21, 24, 27 and 30. Only 4 numbers. Now find the median. Where is the central number? I'll remove 1 over here, 1 over here. So now 2 are remaining at the center. So when we have even number of elements, what we do? We find the mean of the central 2 numbers. Mean, average. So here the average will be what? 24 and 27. Okay. So average of 24 plus 27 is, who can tell me fast? Average of 24 and 27 is, yeah. Okay, I'll do it over here. Everyone try it yourself also. Average of 24 and 27. So 24 plus 27 equals to this 51 divided by 2. So 25.5. So that becomes my mean now. 25.5. Got it, everyone? Whenever you have odd number of elements, it is easy. Whenever you have even number of elements, then it becomes difficult. Okay, just find the central numbers. Now you will ask me one more question. Suppose if the numbers are repeated, then means suppose if the numbers are like this, 21, 24, 27, 30 and then again 30. Then what? Now there are 5 elements. So out of 5 elements, 2 are out, so 27 is remaining. So 27 is the mean. Even if there are same numbers, now imagine, there is one more possibility I'll give you. 21, 24, 24, 24 and 26. Okay, and 27. Suppose these are the numbers. So which is the median? Again, arrange them in serial order. So 1 gone, 1 gone, 24 gone, 26 gone. So 2 are remaining. So 24 plus 24 upon 2. So it is 24 again. 24 is the mean over here. Okay. So even if you have same numbers, then also nothing matters. Keep the logic same. Arrange them in the serial order. Find the central number. That's it. Okay. The average daily wage of 90 workers in the factory is 60. An average daily wage of a female worker is 45. The average daily wage of male workers, if one-third of the workers are male, one-third of the workers are male, is. So what is the question? Firstly, understand that. In a factory, there are two persons, right? One is male, second is female. So there are how many workers are there? Total 90. Out of them, how many are males? Okay, let me write it over here, 90. How many males are here? Males are one-third here. One-third of the workers are males. So, one-third of 90 means 30. How many are females? Females are remaining. So, 60. Right? So, 30 and 60. Now, what about the salaries? Average wages. What is given? The average wage of the factory is 60. So, here the average wage is 60. Then what is given? Average wage of the female worker is 45. So, here the average wage is 45. We have to find the average daily wage of the male worker. So this I don't know. I'll put this as X. And this is what I have to find out. So how to find this out? It's very simple, isn't it? What is the average wage? It is given as 60 over here. So average formula is average. When I am having two elements, it is N1 X1. I'll write it over here so that it becomes easier. N1 X1 plus N2 X2. The whole upon N1 plus N2. Now what is N1 and N2? N1 are the numbers. So this is N1. This is N2. This is X1. And this is X2. Okay. So my answer over here will be average is what? 30 into X plus 60 into X2. Right? X2. It's already given, na? X2 means 45. 60 into 45. The whole upon N1 plus N2. That is 90 then. But average also I know. That is 60. So 60 equals to 30x. What is the answer for this? 60 into 45. Everyone. 60 into 45 is 60 into 45. That is 2700. So that is 2700. The whole upon 90. So I'll just multiply this 90 over here. So 30x equals to, I'll mark it over here. Okay. 30x equals to this 27, this 90 into 6, 9 6 are 54, right? 5400 minus 2700. See, this 2700 will also go on the other side. So it will become minus. So it is 2700. Again, this is 30x. So what is the answer? X equals to 2700 upon 30. So it is 90. So the average wage of male workers is 90 over here. Okay, this is the answer. So the average wage of male workers is 90. Got it, everyone? Clear? Move on. See here. You will get such problems in exam for at least 1 mark. So use this simple formula N1 X1 plus N2 X2 upon N1 plus N2. Okay, you will be able to solve this. Second, when the items included in the sample are based on the judgment of the individual conducting the sample, then the sample is said to be. See here, judgment, whenever it is based on the judgment. So there are two types of sampling. Always remember. One is probability. And second is non-probability or judgmental, we call it. Judgmental. Okay. So two types of sampling. Probability and judgmental. In probability, we have again 4 types of sampling. Which are the 4 types? Simple random. Then systematic. Yeah. Then stratified. And last one is cluster. Okay. Cluster. So these are the 4 types of sampling in probability. And in non-probability or judgmental, we have various: convenience, convenience. Then snowball. Plus there are many, 3 to 4 more. Okay. So what is the main logic behind this question? What is based on the judgment of the individual? So judgment of the individual means the answer will be judgmental, right? So where is the judgmental answer? Random, it means random means probability. Simple random, again probability. So the answer over here is non-random. Non-random means judgmental sampling, where judgment of somebody is used. Okay. Next one. A statistic is a characteristic of. So a statistic is a characteristic of what? See here, always remember S for S and P for P. Always remember this basic formula by heart. S means what? Statistic. Okay, and that is for what? Sample. So whenever I find anything for a sample, that is known as statistic. And P means what? Parameter. Parameter. So that is for what? P is again population. So parameter is for population. Okay. So what do you mean by this? But suppose if I find average or mean of sample. Mean of sample. So then it is called as statistic. Mean of sample is called as statistic. But if I find a mean again, same mean for population. If I find a mean of population, then it is called as same mean. See this, mean is same, but only it is one is for population and second is for statistic. So if it is for population, it is called as parameter. If it is for sample, it is known as statistic. Okay, so statistic is a characteristic of sample. Okay, so that is the answer, sample. So similarly in exam you might get a question on parameter also. Parameter is a characteristic of population. So what are the four main the statistics and parameters? See this, mean, mode, median. Okay, these are the three main. Actually, these are the three ones. Okay, so these are the three main characteristics for statistic as well as population. Whenever I find mode for population, it means parameter. If I find mode for sample, it is called as statistic. Similarly, median. Okay, a sampling plan that selects members from a population at uniform intervals. Here, population at a uniform interval in time order is called as. Just now I gave you the four types of this probability sampling. Okay, one is what? Stratified, second is simple random, third is cluster, and fourth is systematic. So which is this called as? Now the problem over here is, see this point, you have to classify them as per the characteristic. Stratified means what? Suppose if I distribute the students in terms of marks, let's say 40% to 60%, one group. Okay, then 61% to 80%, another group. Okay, and so on. So this is known as stratified. Why? Because I am creating separate blocks between them. 40 to 60 is separate, 61 to 80 or 60 to 80 you can call it. 60 to 80 because somebody might get 60.5% also. So 60 to 80 is separate, 80 to 100 is separate. That is the way. Simple random means what? I'll select any student, just close my eyes and tell that any 10 students from this group should come out. So that is simple random. Okay. So simple random means basically anyone has an equal chance. Now what is cluster? Cluster I divide it as per the region. Means what? I'll divide the students in a, let's say, form a separate, Maharashtra students form a separate group, Delhi students form a separate group, Tamil Nadu students form a separate group. So that becomes a cluster. And last one is the systematic. Systematic means what? I'll tell them, see here, how many students are you? 50. So arrange all these 50 in one line. Every 10th student, just come out. I don't know who that 10th student is. So again, this is known as systematic. So what do you mean by this? A sampling plan that selects members from a population at uniform intervals. Now, which is this? Now, I want the answer from your side. So what is the answer over here? The answer is correct. Systematic, D systematic. Okay. In systematic sampling, I do it as per this uniform intervals. Okay. And stratified, what am I doing? In stratified, I am doing it. Look at this. In stratified, I am doing it. Creating the strata. What do you mean by strata? See, the stratified. Strata means what? I am creating the stairs. What is the staircase? This is the staircase, right? So what am I doing? I am creating like this. This staircase is of 30 to 40. This staircase is of, it's going higher, 40 to 50. This staircase is of 50 to 60. So now tell me, simple logic. The student who is getting 30 to 40%, will he have the same IQ of 80 to 90%? Right? He'll have a different IQ. So that's why stratified sampling has a typical logic that different strata have different IQs or different characteristics. Same strata, all the students within the same range of 30 to 40 will have roughly the same IQ or same qualities. Got it? So that is stratified. You will always get confused between stratified and systematic. Okay. As a general rule, it is not necessary to include a finite population multiplier in computation for a standard error of the mean when the sample size is greater than. Now, what do you mean by this? Understand this properly. Finite population multiplier is used when the population is finite. It is countable. Okay, with respect to the samples. So what do they say? It is not necessary. Where it is not necessary? See here, there are two types of standard errors. See here, everything over here, this multiplier and everything revolves around the standard error. So what is standard error? Standard error. Everything revolves around the standard error concept. What is the standard error? Firstly, let me give you the formula. One is infinite population. See here, there are two types of population. Infinite, which cannot be counted. And second is finite, which can be counted. Okay? Finite, which can be counted. So infinite means what? I can't count this population at all. For that, the formula is standard deviation SD upon psi upon root of n. See this, standard deviation is always written in the Greek form, that is called as psi. Psi. And finite population means again the same, psi upon root of n. Now just multiply this by into, multiply this by this multiplier. This multiplier is known as n minus n upon n minus 1. Okay. This is known as finite population multiplier. I'll just write it. Finite population multiplier, FPM. So that is a question. It is not necessary to include a finite population multiplier in computation of the standard error of the mean when the sample size is greater than. So if I am having the sample size greater than which number, 50, 30, 20 or 10, then I need not use this multiplier. I'll just use this psi upon root of n. So which is the one? How many of you know this? Yeah. It is everyone. Correct. It is 30. If it is more than 30, then you need not use this finite population multiplier. Okay? Hold on. ठीक है ठीक है ठीक है ABM वाली में ओके ओके भेजता हूँ yeah. So next one, the probability distribution of the means for all the possible samples is known as, now look at this, probability distribution of the means for all the possible samples. So if it is for all the samples, then it is known as what? Sampling distribution of the mean, sampling distribution of the population, population distribution of the mean, population distribution of the population. Now these two are totally out. Okay, this is out. This has nothing to do. These two are important. Sampling distribution of the mean or sampling distribution of the population. So what is the answer over here? The answer over here is sampling distribution of the mean. Got it? So that is sampling distribution of the mean. Everyone, subscribe to Officers Adda 24/7 YouTube channel. In this channel, you will be getting number one, the latest updates on JIB and CIB. Whatever IIBF introduces, they give various rulings, various means GRs you can call it. They send various GRs as such, okay, or instructions. So all those are updated immediately. Updates on JIB and CIB. Immediately you'll get it. And second, you'll get a YT series, YouTube series, free YouTube series, free YT series on all the subjects of JIB and CIB. So that's why subscribe to it immediately. Click on the bell icon immediately, isn't it? Whatever is free, grab it fast, very fast, isn't it? The standard error of a mean is a dash of the distribution of the sample means. So standard error, okay, of the mean, what standard error of a mean is a dash of the distribution of the sample means. Quite tricky one answer, but you get this question in the exam for 1 mark. Standard deviation, variance, mean or mode. What is the answer? What do you say, guys? Should be the answer. Standard error of the mean is dash. What is this dash? Okay, I'll again give you one thumb rule which you must remember. Okay, for population, we always use standard deviation. Population, we always use the word standard deviation. For samples, we always use the word standard error. Okay, so what is the answer over here now? What is standard deviation for population is the standard error for sample. So the answer is this, standard deviation. So standard error of a mean is a standard deviation of the distribution of the sample means, isn't it? With increasing sample size, the sampling distribution of the mean approaches dash regardless of the distribution of the population. Very, very, very important question from your module A. It is there in correlation also. It is there in the sampling distribution also. It is a part of estimation also. It is a part of time series also. Same question. Now, what I mean by this? Understand this. Suppose if I am having population. Now I'll show you one chart over here. That is called as normal distribution chart. So this chart is known as normal distribution graph, you call it, or chart, you call it, anything, okay? So this is known as a bell curve. Okay, this is a bell curve. So what happens is, suppose this is the population, let's say. So means it's this bell curve is of the population, let's say. Okay, now this is the population. So population means what? Let's say it is 1000, 1000. Or let me make it bigger, 1 lakh. 1 lakh is a population, means total number of elements are 1 lakh. Now what am I doing? In this 1 lakh, I am finding some samples. I am taking some samples. Let's say I am taking 1000 samples. This is 1 lakh. I am taking, let's say, 1000 samples, 1k samples. Okay. Now what do? I plot these samples, means find the, suppose I want to find out the salary of this this population, complete 1 lakh people. Average, I want the average salary of these. So I can't survey these 1 lakh people at one go. I can't do it, obviously. So what will I do? I can't survey this 1 lakh people. So I take sample of 1000 persons. Everywhere it might be distributed throughout the region. And then I find out the salaries and then I plot it. Now look at this. I'll plot this again. Now this is what am I plotting? This was population. Now I'm plotting this sample. Okay. I'll plot these samples over here like this. So when the population is a normal, see this is normal curve. This is known as bell curve or normal curve. When the population equals to normal, I'll just write n now. So the sample over here, sampling distribution, actually it's not sample, sampling distribution. Okay, so sampling distribution is also equals to normal only. Now there is a second possibility. The population distribution over here is not normal, means it is n, I'll cross it, not normal. Then also the sampling distribution over here will always be normal. So what does this mean? With increasing the sample size, the sampling distribution of the mean approaches what? Skewness, dispersion, normality, or above, all of the above. Regardless of the population distribution of population, means whether this population is normal or not, your sampling distribution will always be normal. Okay. So the answer over here is this normality. Got it? The standard error of a mean decreases with the increasing the sample size. Is it true or false? The standard error of a mean. So standard error of a mean means what? Decreases with the increasing sample size. What is standard error? See this. Let me draw this curve again. In this curve, see this. Now this is known as the population mean, mu. Okay. This is the population mean, and when I draw this, take the samples over here and draw the sample mean. This is known as sample mean, x bar. And this gap is known as the standard error. Standard error. Okay. So what will happen? Suppose if I go on increasing the sample size. Let's say in our earlier example, we had 1 lakh population and then I had 1000 sample. Now what do? Instead of this 1k sample, I'll take, let's say, 10k sample, 10,000. Or I'll take, let's say, 50k sample, 50,000. Or I'll say again 1 lakh sample, complete 1 lakh, I'll take it as a sample. So what will happen when I go on increasing the sample size? See this x bar over here. See here, x bar over here for 1000 is at this point. Suppose if I take all 1 lakh, complete 1 lakh. So where will this 1 lakh x bar move? Who can tell me? It will move towards mu. It will touch mu. It will touch over here. So x bar will be equal to mu if I take the sample of 1 lakh. So what am I doing? As I go on increasing the sample size, the x bar starts moving towards the population mean. So this standard error will go on decreasing. It will reduce. So the answer is true. Isn't it? That's why the answer becomes true over here. Got it, everyone? Large sample size are always good idea because they decrease the standard error. So large samples if I take, are they a good idea? Logically, yes. Here, there are two answers to this. But I'll give you the right answer cost-wise here. Logically, yes. Because as you saw in this earlier example, as I go on increasing the sample size, I am getting this x standard error, I am reducing it. But now tell me one logical answer to this. Okay, yeah, let's say this mu, population mean, is let's say 10. Okay, let's say 10,000 salary. And its x bar is, let's say I am getting this as 9,500. This is the salary I am getting for with 1,000 population. Now tell me, if I increase this 1000 population to 1 lakh, what will be my answer for the sample mean then? The answer will be 10,000. So how much is the difference? I am getting the difference of 500. For that, what am I doing? I am shifting the sample from 1000, I am shifting it to 1 lakh. So sampling 1000 persons versus sampling 1 lakh persons. What is the cost? If per person my cost is let's say 10 rupees, so here 1000 person will cost me 10,000 rupees. Right? Because after all, the one who will do the survey will also charge me. So this will be 1000 for 10 rupees per person. So for 1 lakh, how much will it be? 1 lakh into 10. So 10 lakh. Look at the difference. Here it is 10,000, here it is 10 lakh. And what is the difference I am getting? What is the accuracy which I am getting? Just 500 difference. So the point over here is large samples is always a good idea? No. If the changes in the answer of sample mean and population mean are not too great, then it's not a good idea to have large samples, because cost is very important over here. So that's why the answer is false. Okay. If the mean of a certain population were 15, most of the samples we could take from that population would likely have a mean of 15. So is it so? True or false? Means if the mean is 15, all the points which I am having on that line or wherever, they'll be will have a mean of nearly 15. Is it so? Let me give you an example. Suppose if I draw these points over here. Okay. Now I am finding the mean of this, or I'll draw a line over here which will cover maximum points. See this. So now tell me, are these points near to this line anywhere? This point is so far off. This point is so far off. This point is near. So it's not compulsory that all the points will have the mean of this line only. Okay. Together they are having the mean. Together they are having the mean of this line. But individually they may not have. If these I consider the sample of 50, 50, 50 each, they may not have the answer of this 15 over here. Or if I consider the sample of, let's say, 20, 20, 20 everywhere, all the samples of 20. So they may not have the mean of 15. They may have a huge variation. So that's why the answer is false over here. The total of them, the average of them is the right answer. But individually they may differ. Okay. So that's why this is how many, have you understood this question, whatever I'm telling you? Yeah. Because this is very important from your point to understand. If you understand this, only then you will be able to correlate the same in the exam. Okay. Got it? Move on. Okay. Now let me come to the this batches. Okay. Remember, one sec. See this. These are the two batches. Okay. This is Sankalpa batch English, and there is also bilingual batch. So you can join either of the two batches. Just now started. All the compulsory subjects are covered. Numericals, objective questions, case studies, everything is covered. Join ASAP. Okay. Plus you can join the Mahapack. In Mahapack you are getting multiple. Remember this. In Mahapack you are getting multiple batches. For ABM, BFM, ABFM, all of them, multiple batches. So you get that many times revisions. What all do you get in Mahapack Extra? Live classes, video courses, e-books, test series, mini and Maha marathons, practice papers, doubt sessions, everything you use. Use the code JC80 for getting maximum discounts. Let me show you how to get those. Okay. Go to Adda 24/7. Okay. Let me go to Adda 24/7. I would always suggest you to go through the app. Okay. Because in the app, what happens? You are getting this coin system. In coin system, you are getting 1% extra. Okay. So, because what happens in coin system, as you go on collecting the coins, you get discounts. So that discount ranges to around 1%. So that's why go to Adda 24/7. Hold on. See this. Now you are on Adda 24/7. Yeah. So here, what you do? Click on JIB and CIB over here. JIB and CIB. Click on CIB November 23. Click. Now you will see the batches. Look at this Sankalpa batch. Click on this Sankalpa batch. Now you will see the details. See this. Recorded sessions, interactive videos, limited interactive classes, limited size batches, everything you are getting. Recorded means what? If you miss out on any class, you can definitely get back to it. Okay. Interactive classes, you can ask the questions there and then itself. Use the code JC80. Now look at this. 80% off is going on. 4799 already applied. Look at this. 80% off you are already getting. So 23,999 reduces to 4799. Use this immediately and join it ASAP. Exams are very near. Also, how to join the Mahapack? Let me show you the Mahapack. Okay. In Mahapack, go to Adda 24/7. See the JIB, CIB Mahapack. Now click on this CIB ka Mahapack. Here you will get the details. Okay. Means Look at this. Recorded videos, interactive classes, limited size batches. You can go through the product details over here. Okay. Click on buy now. See, this code is already applied, JC. So the validity has become 24 months. For Mahapacks, it is a double validity now. Plus the fees is 80% off. So it's a huge offer to you. Join it ASAP. Exams are very near and you don't have time to study later. So join immediately. Okay. And I'll be back tomorrow with another series. Till then, bye. Keep studying. Okay.